Okay, so next we'll see what is beam width. Okay, beam width. So already you have some idea about beam width, because once if you have a radiation pattern, then you can find out beam width. Okay, beam width. Okay, beam width. So if I have an antenna like this, if I am having antenna here, I measure the radiation pattern. If the radiation pattern goes like this, the radiation pattern is in this way. So this is the direction of E max. Okay, this is E max maximum, because once if I stand in this direction, then I'll get the maximum electric field. If I move in this way, then I'll get the minimum electric field. Please don't think that when you move away, your distance is actually constant. Okay, when you move away from this point, actually you are moving like this, but this indicates how much power you will receive. Okay, you are moving along a fixed direction. See, please always note down that whenever you have a field pattern like this is your movement. Dotted line is your movement. Okay, what it indicates, how much power you will receive. When you stand here, you will get some maximum power. When you go here, your received power will decrease, decrease, decrease. Then once if you come here, then exactly zero. And this in this direction, there is no power. And once if you move, start moving in this direction, then you get some power, and your power received is increases. Then it becomes maximum. So whenever I put a radiation pattern like this, please don't imagine that you are moving on the radiation pattern. You are not moving on the radiation pattern. You are moving on the fixed path, okay, circular path. But this indicates how much power is received by your handset. Okay, so this is the maximum. So then when I stand here, I may get some maximum power by root 2. I may get, see here I am getting 100% of the power, then 90%, 85%, 80, 75, it goes like this. So when I stand at some position, I will get 75% of the power, then I will mark that power. Okay, I will connect the line. Okay, so between this one, then it will mark somewhere here. Say, if it marks here like this. So what is the meaning of this one? So once if I stand here, what is the meaning of this one? Once if I stand here, I will get 70% of the power. Similarly, you connect these two. Once if I stand here, I'll get 70% of the power. So once if I go beyond this direction like this or like this, I will get less than 70%. I will get less than 70%. So roughly that is E is equal to, so in this case, my E, what is the electric field that I am getting, that is equal to E max. What is the E max value? What is this value divided by root 2? Okay, because once if you take root 2 upward, then that is roughly 70%. So this also, here also the value is E max divided by root 2. E max divided by root 2. Okay, then you have two line, okay, that is meeting at some point. Then you can easily find out angle between this line. Angle between this line. This angle between this angle is called beam width. This angle is called beam width. That angle is named as HPBW, half power beam width. Okay, this angle is called half power beam width. Okay, so what is HPBW? So whenever beam width is given, or otherwise if they are not giving HP, if simply they give the beam width, BW means mostly it will indicate the half power beam width, unless otherwise it is mentioned as full power beam width. Okay, full null beam width. If they mention as simply BW, most probably their aim is to denote the half power beam width. So or specifically they may mention HPBW, that means what? Half power beam width. Okay, half power beam width. Power beam width. Okay, now you know that once if the electric field is off, you know that, so when E is equal to E max, okay, divided by root 2, when your electric field is like this, then what is the power value? Power is always what, sir? Electric field square. Okay, power means always what? Electric field square. Then what is the, so everything what I am mentioning here is RMS. Please imagine that whatever I am working with here is RMS. Okay, once if you have this much power here, okay, see if E max divided by root 2, if electric field is E max divided by root 2, then once if you square, simply if you square the electric field, and then what is the value? E max, okay, E max divided by root, or otherwise um, see, I can say like this, please wait a bit. So when I have Emax, let it be RMS or actual value. When E is equal to Emax, definitely at this point, power is equal to Pmax. Okay, so at that point, you'll get maximum power. So, but when E is equal to, wait a bit, when when E is equal to E max, P is equal to P max. When E is equal to E max divided by root 2, when E is equal to E max divided by root 2, you know that once if you calculate the power, then simply this is the square of this one. So once if you take square, then that is simply P max divided by root 2. So what is the meaning? Once if your electric field is becomes 1 by root 2 means indirectly your power will become 1 by 2. Okay, once here if you are getting maximum power here, once if you come here and you measure your power, okay, in terms of watt, then you will get half of the power. Okay, electric field means 70% electric field, power means 50% of the power, you know, from the circuit analysis point of view also. Okay, so whenever you calculate the power 50%, if you calculate the voltage or current, that is roughly 1 by root 2 times or 0.707 times. Okay, so that's why these 2 point is called half power beamwidth. This 2 point is called half power beamwidth. Okay, then next question is, then what is the beamwidth between the nulls? Okay, see, if I am having the beamwidth like this, okay, I am having a beamwidth like this. Now what I have to draw? I have to draw a line tangent. I have to start here. I have to draw tangent to this diagram. Once if I draw tangent to the diagram, it goes like this. Okay, similarly, if I draw like this, it goes like this. This value is called beamwidth between the nulls. Okay, so in this case, generally they used to mention as beamwidth between the first null, because I'll explain what is first null or second null like that. But please imagine this is the beamwidth between the nulls. Okay, so beamwidth between beamwidth between the first null. Okay, then what is the relation between this one beamwidth BWFN? This is BWFN, and this is half our beamwidth. In general, the relationship is like this. Okay, see, beamwidth between the first null is equal to roughly approximately 2 times of half power beam. 2 times of half power beam. Another important relationship. Okay, beamwidth between the first null is equal to generally 2 times the half power beamwidth. Okay, by experience, once if you solve 1 or 2 problems, then you will come to know. Okay, if you take some function, then you analyze the function, then you will come to know whether this is working or not. Okay, so later, if time is there, I'll take some examples to prove this. Okay, next. Next, then what is the relationship between the beamwidth and the directivity? What is the relationship between the beamwidth and the directivity? Okay, I told you in the previous class itself. Say it may be like this. Say this is the case 1. If this is the case 2. Okay, case 2. Then definitely in the first case, beam width is high, but directivity will be less. In the second case, beam width is less, but the directivity is high. So the beam width and directivity is always inversely proportional to each other. Okay, if directivity decreases, beam width increases, or otherwise if directivity increases, beam width decreases. I think already I have given you the relation. So always remember directivity is inversely proportional to beam width. Directivity is inversely proportional to beam width. Okay, so that's the idea.